In this tutorial, we're going to talk about the heat transfer mechanisms. And there are three of them. The first one is conduction. For instance, if we have a hot body and a less hot body, then there is going to be an interaction between molecules. So in this case, for conduction, we need contact. What is happening? The molecules of the hot one, which have a lot of kinetic energy, are going to collide with the ones which are cold, and they are going to be, the kinetic energy is going to be transmitted due to collisions. This usually happens between bodies which are solids. This is defined by the so-called Fourier's law. Fourier's law states that the rate of transfer, which is for instance the thermal power, heat over time, is going to be equal to minus K, which is the conductivity, and this is dependent on the system, times the area, the transverse area, times the change in temperature due to a surface. Once again, the parameters that are applying here is a transverse area, there is going to be a gradient of temperature, there is going to be a thickness, and a parameter which is dependent on the object we are talking about, which is the thermal conductivity. The thermal conductivity, once again, is a property of a given material. Its units are watt per meter degree Celsius. This is an international system. We can also have units, for instance, in English system of BTU per second feet degree Fahrenheit. Remember, since we are working with a change in temperature, it is exactly the same to have Celsius than Kelvin. It is exactly the same to have Fahrenheit or, for instance, Rankine. We are working with a change in temperature, which is, in Fourier's law, the gradient of temperature. Convection involves a motion of a fluid. There are two of them, natural convection and forced convection. When we're talking about natural convection, we're talking about a system, for instance, which has a certain temperature. What is going to happen? Well, the system which has a temperature higher, for instance, than the temperature of the environment, so for instance T1 is higher than the temperature of the environment, then the first layer, which is for instance the layer of air, is going to be hotter than the next layer. So for instance, this is going to be hotter, then this is going to be less hot, then this is going to be less hot, right? Since the density is, for instance, a mass over volume, but the volume is also temperature dependent, higher temperature systems will have lower density, right? So if temperature increases, then the density is going to decrease. And if this happens, then the buoyant force in this layer is going to start to act. So this will start to rise, and then it will generate a motion which we, for instance, see as vapor. This is natural convection, and this is due to buoyant force. The forced convection is, for instance, if we have a system which is, for instance, providing energy or motion, providing more motion. This could be, for instance, a fan or some magnetic stir bar. So this is a forcing convection. Convection is studied by Newton's cooling law. The third phenomena or mechanism of heat transfer is called radiation. And radiation is, for instance, due to electromagnetic interactions. So, for instance, we have electromagnetic waves that are traveling through space, for instance, and that's how we receive from the sun, the radiation of the sun. We receive, for instance, electromagnetic radiation. This electromagnetic radiation is studied by Stefan Boltzmann law, and this is due to the electromagnetic interactions which have energy. So basically we studied conduction with Fourier's law, we studied the convection with Newton's cooling law, and we studied radiation with the Stefan Boltzmann law. These are the three mechanisms of heat transfer.